Hello, brothers and sisters. Today, I'm going to talk about your standard units, significant figures with conversions in one-step process, and the prefixes for your units. So let's go ahead and jump into this and see if we can learn something. All right. So here we have our standard units. Okay. We're talking about the metric system. That's going to be the main system that we use in chemistry. And we also use the SI units. And so here are our SI units, which are basically the same as our metric units with some small differences. The main difference is in temperature, that we use the Kelvin system in SI units rather than the metric system of Celsius. So most people understand Celsius. Here in America, we use Fahrenheit. I'm not going to get into that, but this is superior to Fahrenheit and this is superior to Celsius, only in that this Kelvin doesn't have any negative values. All right, so physical quantity, it's really important to understand that the physical quantity of something is the the physical thing that you're measuring, right? So when you're measuring meters, the physical quantity that you're measuring is length, right? So if you want to measure mass, generally the base unit is going to be the kilogram in SI units. In the metric system, it's going to be the gram. The reason why the SI units uses kilogram is because that's more um, related to the human body. A gram is very, very small compared to the human body, whereas a kilogram is proportional, right? The meter is the base unit for length in both systems. For mass, as I said, kilogram for SI and gram for metric. For time, it's second for both. Temperature, we have Kelvin for SI and Celsius for metric. And for volume, we are talking about liter for SI and also liter for metric. And then for the amount of substance, it's going to be moles in both cases. Okay, moles. Um, Now, if we need to talk about the symbol. So the symbol for the meter is an M, small m. The symbol for kilogram is kg. Okay, kilo we'll talk about in a minute, but for gram, it's just G. Second is S. Kelvin is a capital K. Celsius is going to be let's just do it here, degree C, right? So that's Celsius. Just like Fahrenheit is degree F, but Kelvin does not have a degree symbol because it's an absolute temperature. Then with volume, it's just going to be the capital L for liter. And for the amount of substance, the symbol for mole is MOL. We just dropped the E. Okay, so that's our units. Let's talk now about the prefix multipliers. Okay, so the prefix multipliers are the thing that you're going to multiply the base unit by in order to get to the unit that you were talking about. So this is useful for very large or very small numbers, right? And so what you need to know is that, and there's a lot of them here, right? I wouldn't memorize all of them, but I would get started on trying to memorize as many of them as you can. The most important ones are going to be kilo is going to be the most important, and milli also very important. We use those quite a bit. We also use micro quite a bit and nano quite a bit. And then centi comes in there as well. Deci isn't used all that often, but might as well memorize that one as well. Those are the ones that I would start with memorizing. Mega might be another good one. The easy way to memorize these, though, is that mega is 10 to the 6, so that's a million, right? Um, Kilo is 10 to the 3, that's 1,000. Deci is 10 to the negative 1, so that's going to be 1/10. Centi is 10 to the negative 2, so that's 1/100th. And then we get to milli, which is 10 to the negative 3, so that's 1,000th. And nano is 10 to the negative 6. Sorry, micro is 10 to the negative 6. That's a millionth. And then nano is 10 to the negative 9. That's a billionth, 1 billionth, right? So nano and giga are kind of opposites to each other. Giga is the big version of what nano is. So giga is 10 to the negative, or sorry, 10 to the 9, and nano is 10 to the negative 9, right? So anyway, those are how we use those. So basically what you want to do is, let's take nano, for instance. Nano, we've screwed this down just a little bit so you can see what I'm writing here. N is equal to 10 to the negative 9, okay? And if that's true, then nanogram is equal to 10 to the negative 9 grams. And so this means that 1 nanogram is a very, very small portion of a gram, right? People often get this backwards and think that it's 10 to the negative 9 nanograms per gram, and that's not true, right? Just remember that nano means 10 to the negative 9. These are the numbers that I would memorize with these symbols, okay? So let's go ahead and do some little problems here. Write the following with a single letter symbol to represent the prefix with the given multiplier. So 1,000. 1,000 is going to be kilo. So we just write a small k here. 100. That the th there means that it's 1 divided by 100. So that is going to be centi here, okay? Centi. So it's a C. 1 million. So that's 10 to the 6. And that's going to be mega, capital M. 1 billionth. So with a th, that means that it's 1 divided by a billion, and a billion is 10 to the 9. So that means that it's going to be nano, 10 to the negative 9 nano. 1 billion means 10 to the positive 9, and that's going to be giga. So capital G. All right. So write the name of the unit for the following symbols and then underline the name of the metric base unit. So write the name of the unit for the following symbols and then underline the name for the metric base unit. So this is going to be NM is nano, and then M is meters. And then we're supposed to underline the name of the metric base unit. The metric base unit is going to be meter. Okay. Milliliter. So that's milli. And then, oh, sorry, that's supposed to be 2 L's. Milliliter. Okay. And so the metric unit here is liter. Okay. This is microsecond. So microsecond. And so second is the base unit. And then kilogram. Kilo. Oh, sorry. Kilogram. And gram is the base unit. Actually, well, yeah. So for gram, the base unit for SI is kilogram. So really, I could underline the whole thing here and say that is the base unit, right? Okay, so then let's talk a little bit about metric conversion factor. So when we have an equality statement, and here's an equality statement here, 1 kilogram is equal to 10 to the third grams, or 1 nanogram is equal to 10 to the negative 9 grams, right? 1 nanometer is 10 to the negative 9 meters. So these are 3 different examples of equality statements, and we can do that with any unit and any multiplier that we want. Then you can make 2 conversion factors out of that. So just remember that if I have A equals B, right? And I want to, if I divide this by B, divide both sides by B, then this becomes equal to 1. And that means that 1 is equal to A over B, right? So if I take this conversion factor, 1 kilogram equals 10 to the third grams, and I divide both sides by 10 to the third grams, this then is equal to 1. So if kilogram over 10 to the third grams is equal to 1, then that is also equal to 10 to the third grams divided by kilogram, right? And so that's how we come up with our two conversion factors. And we'll be using these in order to cancel units out in our dimensional analysis that we'll be doing soon, okay? So just to give you another example, okay? Another example would be 1 nanometer is equal to 10 to the negative 9 meters, right? So we can rewrite this as 1 nanometer over 10 to the negative 9 meters, or 10 to the negative 9 meters over 1 nanometer. So that's our conversion factors here and here, right? And for this example up here, we would have nanogram over 10 to the negative 9 grams, or 10 to the negative 9 grams over nanogram. Okay. So those are our conversion factors that come from our prefix multipliers along with our units, right? Units stuff. So, all right. So let's kind of put all that stuff together here and do this one. All right. So 1,000th of a gram. So let's go back over to our thing here. It says 1,000th. So that's 1 divided by 1,000. 1 divided by 1,000 is milli. Okay. And then we're talking about a gram. So the full name of the unit would be milligram. This 2-letter symbol would be small m for milli and small g for gram. And then the equality statement would be that milligram is equal to, milligram, 10 to the negative 3, 10 to the negative 3 grams. All right. So now let's look at 1/1000th of a meter. 1/1000th of a meter. So 1/1000th is 10 to the negative 9. That's nano. So nano. And then meter. So that would be nm. And so nm is equal to 10 to the negative 9 meters. Okay. 1/1000th of a second. So 1/1000th is going to be 10 to the negative 12. 1/1000th, 10 to the negative 12. That's going to be pico. Okay. So we have pico, and that was second. Picosecond. So that would be PS, and that would be PS is equal to 10 to the negative 12 seconds, right? Hopefully this is making sense to you guys. All right, so 1/10 of a meter. So a tenth of a meter, this is a tenth, right? This is a tenth. That's deci. So deci meter, a decimeter. This is dm. And so dm is equal to 10 to the negative 1 meter. All right. Now let's do the next one. So 1/1000th of a Kelvin. 1/1000th of a Kelvin. So a million is 10 to the negative 6. So that's micro, right? So micro. And then Kelvin. So microkelvin. So this would be a small m, a capital K. Okay. And so small m, capital K is equal to 10 to the negative 6 Kelvin. All right. 1 million liters. 1 million is 10 to the 6. So that's going to be mega, right? So mega and liters. liters. There we go. So this is going to be a capital M and then a capital L. Okay. Because remember, the base unit for liter is a capital L. All right. So mega liter then is equal to 10 to the 6 liters. It's a pretty big volume, right? Okay. 1 million liters. 1 billion grams. That's a big number. 1 billion is 10 to the 9. So that's a giga. Okay. So giga. And then grams. So capital G, small g. GG. There we go. So GG is equal to 10 to the 9 grams. All right. All right. Let's do something different now. How many grams equals 1 kilogram? How many grams equals 1 kilogram? So 1 kilogram is equal to, well, let's go back to our list here again. Kilo is 10 to the 3. So it's 10 to the 3 grams. 1 kilogram equals 10 to the 3 grams. Okay. If A equals B, what is the numerical value of the quantity A over B? Well, I went over that a minute ago. The numerical value is 1. It equals 1, right? If the mass of an object is 1 kilogram, is this the same mass value as an object of 1,000 grams? Well, 1 kilogram equals 10 to the 3 grams, which is equal to 1,000 grams. So yes, 1 kilogram is equal to 1,000 grams. If you start with the quantity of 1.28 kilograms and multiply it by the quantity of 1,000 grams per kilogram, do you have to change the quantity? Quantity is the number, right? And so the question is why or why not? Well, let's go ahead and look at this. 1.28 kilograms. We multiply this by 1,000 grams per kilogram. Well, if we do that, we're going to multiplying this by 1,000 gives us 1,280, right? Because we're going to be moving the decimal 3 places over. And then kilograms cancel out. So we're going to be in grams. So do we change the quantity? Well, we're changing the unit, but we're not changing the quantity. It's still the same mass, right? So it's still the same mass. So no, it's still the same mass, but the unit is different. Okay. So the unit is different. And so the numerical value is different, but it's still the same quantity. Does that make sense? Okay. If you multiply 1.28 kilograms by the quantity 1,000 over, this is here. I did it already. Do you change the units? Yes, we do, because as I said, the kilograms are going to change. That should be a small g, and this should be a small g. So the units change, yes. So 1,280 gram. The new number with the units is going to be this. Okay. The units do change. We cancel that out. Note the answer tells you how many grams are in 1.28 kilograms. Does it make sense? Yeah, it makes sense that there's 1,280 grams in 1.28 kilograms, because this is just 1,000 times bigger than this unit is 1,000 times bigger than this unit. So yeah, it does make sense. All right, now let's make some conversion factors based on these equalities. So we have an equality here. We want to make 2 conversion factors, okay? So the first one we'll do is say 1 nanometer over 10 to the negative 9 meters. And then the next one we'll do the opposite way. So 10 to the negative 9 meters over 1 nanometer. Next one, 1 kilometer over 10 to the 3 meters, and then 10 to the 3 meters over 1 kilometer. Picoseconds. I'm going to do this one. I'm going to do this on each side of this. This might make it a little easier for me. So 1 picosecond over 10 to the negative 12 seconds, right? And then the other one would be 10 to the negative 12 seconds over 1 picosecond. We'll do this one over here. 1 megaliter over 10 to the 6 liters. 10 to the 6 liters over 1 megaliter. Okay. Gigagrams. Okay. So that would be 1 gigagram over 10 to the 9 grams, or 10 to the 9 grams over 1 gigagram. And then the last one is milligrams. We have 1 milligram over 10 to the negative 3 grams, or 10 to the negative 3 grams over 1 milligram. And you'll see why we're doing this in a minute when we actually do some calculations with these conversion factors. So let's go ahead and do a conversion factor. So we want to convert 20.0 nanometers into meters. Okay. So the conversion factors for this, we did this here. We have these two conversion factors, right? So if we write here 20.0 nanometers, what we want to have is we want the nanometers to cancel out. So up here, I'm going to do it the wrong way. So 20.0 nanometers. If I multiply it by this conversion factor, 1 nanometer per 10 to the negative 9 meters, what I end up getting is that my nanometers will multiply by each other, and I'll get, well, let's just do the calculation here. Where's my calculator? Oh, sorry about that. For some reason, that just fell right over. Should have had my calculator out already, but I didn't. All right, so here we go. Um, so 20, then divide that by, put in parentheses, 10 to the negative 9, and then in parentheses. So we get 2 times 10 to the 10, be 2.00 times 10 to the 10, and that would be in nanometers squared over meters, because nothing cancels out, right? And believe it or not, it's just got funny units. But this would mean the same thing as what I'm going to do here. What I do here is I do it using this conversion factor. So 10 to the negative 9 meters over 1 nanometer. And now my nanometers cancel, nanometer divided by nanometer, and I'm left with units in meters. And so what I really have here is 20.0 times 10 to the negative 9, or 2.00 times 10 to the negative 8. And the units here are going to be meters, right? This is a better answer. Does that make sense? I hope that makes sense. All right. So instead of showing, so this way was the wrong way. That gives you units that don't work out, right? Let's do the rest of these. We'll do them in only the right way. So here we have 0.0187 liters. We want to go from liters to milliliters, right? So we want to go from liters to milliliters. And we didn't actually do that one here, but we can do that real quickly. Let's go over here. We look at this. Milliliters would be, milliliter is equal to 10 to the negative 3 liters, right? So this, our conversion factors would be milliliter over 10 to the negative 3 liters, or 10 to the negative 3 liters over milliliter, right? So I'm going to go over here. Which one of these I want to use? I want the liters to cancel out. So the liters will be on the bottom. So we'll do multiply this by 1 milliliter over 10 to the negative 3 liters. Okay. And clear 0.0187 divided by, oops, 10 to the negative 3 equals 18.7. That'd be 18.7 milliliters. My liters cancel out. All right. Micrograms to grams. We didn't do micrograms to grams, but we can figure it out. We know that microgram equals 10 to the negative 6, right? So microgram equals 10 to the negative 6 grams. Okay. We have 3.41 times 10 to the 5 micrograms. We want to go to grams. We'll multiply this by grams, 10 to the negative 6 grams divided by 1 microgram. Okay. So now my micrograms cancel out. I'm left in grams. So this is 3.41 times 10 to the negative 6. Oops, say that. 3.41 times 10 to the 5 times 10 to the negative 6. Can't forget that, right? Got both of these parts here. So my answer becomes 0.341. So this is 0.341 grams. Okay. And that makes sense because we got 10 to the 5th of these, and then we're going to do 10 to the negative 6 of this. So it's just going to move the decimal one place over. All right. Let's do another one here. Seconds to picoseconds. I think we had the picoseconds one. Yeah, we did. So we have two conversion factors for picoseconds, this one and this one, right? We have 5.7 times 10 to the negative 8 seconds. We want to go to picoseconds. That's a seconds, not a grams. So we want to have picoseconds on top, right? So 1 picosecond divided by 10 to the negative 12 seconds. All right. Now our seconds cancel out. And we do the calculation here. 5.7 times 10 to the negative 8 divided by 10 to the negative 12 equals 57,000 equals 57,000. Now, I did not go through these to do sig figs at this point. We have 2 sig figs here. So really, this is perfectly fine. We can keep that as 2 sig figs right there. But it's going to be in picoseconds, right? We need to have that there. A better way to write this would be 5.7 times 10 to the 4, right? 1, 2, 3, 4. So the 10 to the negative 4, that's picoseconds. Over here, we had 3 sig figs. So we have 3 sig figs. Here we have 3 sig figs. We have 3 sig figs. 3 sig figs, 3 sig figs. So we're doing it right. I just wasn't just pointing it out to you. All right. Next one, we have 325 micrograms. We want to go to grams, right? So the conversion factor for micrograms, we haven't done that, but let's just look at the equation. So microgram is 10 to the negative 6 grams, right? So we can say we want the grams on top. So that would be times 10 to the, it's in micrograms, 10 to the negative 6, 10 to the negative 6 grams divided by a microgram. And the micrograms cancel out, and we got it. Okay. So let's do this calculation. 325 times 10 to the negative 6 equals, and that would be 3.25 times 10 to the negative 1, 2, 3, 4, right? To the negative 4. And that would be grams. All right. And then, so 3 sig figs again. Last one, 1.01 times 10 to the negative 8 seconds. And we want to go to nanoseconds, right? So we want nanoseconds on top. So 1 nanosecond over, and how many seconds are there in a nanosecond? I think I did that one over here. No. Okay. So nano is 10 to the negative 9 seconds, right? 10 to the negative 9 for nano. Okay. So 10 to the negative 9 seconds. Right, this should be an S. There we go. So seconds will cancel out. And so we have 1.01 times 10 to the negative 8 divided by 10 to the negative 9 equals 10.1 nanoseconds. Right? Okay. So that's that. That's one-step conversions within metric. So the last thing that I wanted to do here, oh no, I guess I have a couple more pages here I wanted to go through. So on this page, we're talking about conversions between the imperial system or the American system and the metric system, right? So we have kilometers to miles, meters to inches, yards, centimeters, feet, inches, whatever, right? Kilogram, pounds, ounce, grams, and all these kinds of things. Liter and so this is all metric here, but liter to quarts and gallons to liters are there. So let's go through these questions here and see how we work. Okay, so how many centimeters equals 1 inch? So 1 inch is equal to 2.54 centimeters. 2.54 centimeters. Use the equality statement for inches to centimeters to write two conversion factors. So two conversion factors. 1 inch per 2.54 centimeters, or 2.54 centimeters per 1 inch. How many significant figures do you need to use for 2.54 centimeters? This is, because it's an exact number, says exact here, this is by definition true. And so this has infinite sig figs. So infinite sig figs. If you start with a given quantity, 10.35 inches, which conversion factor do you need to use for dimensional analysis to ensure the units cancel out? So if I start with 10.35 inches, I need to put the inches on the bottom. So I need to multiply this by 2.54 centimeters per inch. If you multiply 10.35 inches by the quantity 2.54 centimeters over 1 inch, do you change the units? Yes, the units will change, and this will be in centimeters, right? What is the new number with the units? Well, let's do this. So clear, 10.35 times 2.54. This is going to give us 26.289. This does not limit our sig figs. This does. So that's going to be 4 sig figs. So 26.30 centimeters. That is the answer to this question here with the units. Why should your answer from the previous question have 4 sig figs? Because there were 4 sig figs in the original given value, and this is an exact number and has infinite sig figs. If you have an object that weighs 435.59 grams, how many pounds does this weigh? Well, let's go ahead and see. So we have, okay, finish the equality statements. So 1 pound. So how many pounds equals 453? 1 pound equals 453.59 grams. So 1 pound equals that. How many pounds is in this weight? Well, that's 1, right? So basically what we would do is we have 453.59 grams times 1 pound over 453.59 grams. That cancels with that, and this equals 1 pound. But really, the number should be 1.0000 pounds because we have 4 sig fig here, and this is an exact number. Oh wait, no. This also has 5 sig figs, so 5 sig figs. Okay, hopefully that makes sense. A roll of bare copper weighs 250 grams. Use dimensional analysis to calculate the mass of copper wire in pounds. So we have 250 grams, that's 2 sig figs, times 1 pound over 453.59 grams. So grams cancel. And so this would be 250 divided by 453.59 equals 0.55. We only have 2 sig figs, right? So 0.55. 0.55 pounds. All right. Do your units cancel out in your previous answer? Yes. Why does the correct answer only have 2 significant figures? That's because there was only 2 significant figures in this problem, in this one here. All right. Last page, let's do some conversions here. Okay. We have 165 pounds and we're going to kilograms. So we have 165 pounds. We're going to need to convert from pounds to kilograms. So what do we have? There's our conversion. So we want kilograms to be on top. So we'll go 1 kilogram per 2.205 pounds. And now our pounds will cancel out and we'll have our answer. So 165 divided by 2.205 equals, and so we have 3 sig figs here, 4 sig figs here. We're going to go with 3 sig figs. So 74.8 kilograms. 12 ounces. We want to go to grams. Okay. So 1 ounce equals 28.35 grams. Okay. So multiply this. We want the ounce to be on the bottom. So we're going to multiply this by 28.35 grams per ounce. And then our ounces cancel out. So this is 12 times 28.35 equals, and so we're going to need 2 sig figs here. So that's going to be 340. All right. Timberline Lodge just received 62.25 inches of new snow. Calculate the depth in centimeters. So we have 62.25 inches. And now we want to convert to centimeters. We have that 1 inch is equal to 2.54 centimeters. We'll put the centimeters on top, divide by the inches, right? 2.54 centimeters per inch. And so 62.25 times 2.54 equals 158.11. So how many sig figs? We have 4 sig figs here, an infinite number of sig figs here. So we go with 4. That's going to be 158.1. 158.1 centimeters. The inches canceled out. And the last one now, we have 174.2 miles. We want to calculate the distance in kilometers. So 1 kilometer is equal to 0.6214 miles. Okay. So we're going to put the kilometers on top. So times 1 kilometer over, excuse me, 0.6214 miles. Okay. And then our miles cancel out. So just make sure you get this right? Sometimes people will make the mistake. Oh, you can't see this here. Sometimes people will make the mistake and put the 0.6214 on the kilometer side, and that's not right? So it's with the miles. The miles cancel out. So when we got 174.2 divided by 0.6214 equals 280.33, and we only have 4 sig figs in each of these, so we'll go with 280.3. 280.3. My miles cancel out, so that's in kilometers. All right. Well, that's a wrap, and I hope you guys learned something. Let's there it is. Stop share, and we'll see you guys in the next one. Take care.